In this video, we will explore several more examples of finding maximum and minimum values of a continuous function on a closed interval. And recall from the max-min property, these maximum and minimum values can occur at two types of points. A critical point of our function inside the interval, that is a point where the first derivative is 0, or at one of the actual endpoints of the interval. So the first step is to find the critical points inside our interval. So inside from minus pi over 4 to pi over 6. So in order to find those critical points, we differentiate our function. So the derivative of sine is cosine. And then we solve where is cosine equal to 0. And cosine is equal to 0 when we are at pi over 2, and then plus or minus any multiple of pi. So infinitely many points, so we think dot dot dot, there's kind of the minus 3 pi over 2, minus pi over 2, pi over 2, 3 pi over 2, and so on. And what we have to do is pick any of those points inside our interval. But it turns out in this case, none of those points are inside our interval. So we have critical points. So let's see, if we're at 0, we have a critical point at minus pi over 2 for the function, and positive pi over 2. But our interval is from minus pi over 4 up to pi over 6. So the interval that we are interested in does not contain any critical points. So in this case, we would just simply say no critical points inside our interval. So inside that interval from minus pi over 4 to pi over 6. So the second step is to evaluate the function values at the endpoints and any critical points inside the interval. There are no critical points inside the interval, so we just need to evaluate it at the endpoints. So f of minus pi over 4 is sine of minus pi over 4, which is a common value. This is minus 1 over root 2. Pi over 6 is also a common value for sine. Sine of pi over 6 is the number 1/2. So we have a minimum value corresponding to the input minus pi over 4, and a maximum value corresponding to the input of pi over 6. And let me just point out that if you think about this from a graphical perspective, this makes very, very good sense. So if we were to sketch the graph of sine going from minus pi over 4 to pi over 6, and I'm going to go ahead and just sketch it from minus pi over 2 to pi over 2. So at minus pi over 2, the value of sine is minus 1. Then at 0, it's 0. And then at pi over 2, it's 1. So if you look at what's happening from, say, minus pi over 4 up to pi over 6, our function is just getting bigger and bigger. So the smallest value, the minimum, occurs at the left endpoint. The biggest value, the maximum, occurs at the right endpoint. So let's go through another example. Let's find the critical points and determine the maximum and minimum value of our function, x over x squared plus 1, on the interval from 0 to 2. So once again, our first step is to find the critical points of our function on the interval from 0 to 2. So in order to find those critical points, I differentiate my function and then set it equal to 0 and solve. So f prime of x, we are differentiating a quotient, x over x squared plus 1, so we apply the quotient rule. The quotient rule tells us low d high, the derivative of x is 1, minus high d low, the derivative of the bottom is 2x, all divided by low squared. And then we just algebraically simplify a bit. We have an x squared plus 1 quantity squared in the bottom. In the top, what we are going to have is x squared and minus 2x squared. So x squared minus 2x squared is a minus x squared, and we also have a 1. So 1 minus x squared. And what I would like to know is, where is this equal to 0? And if you have a fraction that's equal to 0, that simply means the top has to be 0. So the only place that this can be 0 would be where 1 minus x squared is 0, which is equivalent to saying that 1 is equal to x squared. So x is equal to plus or minus 1. So the critical points for our function are going to be x equals plus or minus 1. But just note, only the critical point x equals 1 is in the interval that we are interested in. So in the interval from 0 to 2. So when it comes to this second step of determining those maximum and minimum values, we need to evaluate the function at 3 points. The endpoints of the interval, so 0 and 2, and any critical points inside the interval. So in this case, by inspection, f of 0 is 0, f of 1 is 1/2, and f of 2 is 2/5. So the smallest number we see here is 0, so that corresponds to the minimum value. And 1/2 is just a bit larger than 2/5, so that corresponds to the maximum value. So let's look at one more example of finding maximum and minimum values of a continuous function on a closed interval. So our first step is to find the critical points of our function inside this interval. So we differentiate, so it's a polynomial going term by term. 4x cubed minus 4x plus the derivative of 3, which is just 0. And what I would like to know is, for this derivative, where is it equal to 0? So I want to algebraically solve this. So each term involves a 4 and an x, so I can pull that out. I will be left with an x squared in the first term and a minus 1 in the second. And x squared minus 1 is a difference of squares, so that's x minus 1, x plus 1. So we see 3 solutions here, which will be our critical points. X equals 0, x equals 1, x equals minus 1. So these are the critical points that we are looking for. Now each of these critical points are inside our interval from -2 to 3. So the maximum and minimum value can occur at 5 possible points here. The endpoints or one of the critical points inside. So we need the function values f of -2, f of -1, f of 0, f of 1, and f of 3. So if I go ahead and just evaluate the function, and feel free to use your calculator here when doing so, f of -2 is the number 11, f of -1 and positive 1 are both 2, f of 0 is just that constant term 3, and f of 3 is 66. So looking at my list of numbers, I see a very obvious largest value, 66. That's going to be the maximum value. And then we see the smallest number as well, 2. So the minimum value, 2, occurs at plus or minus 1. And how we could denote this is just say f of the input plus or minus 1. Regardless of which input we plug in, we get an output of 2. So we have our minimum value and our maximum value.